Okay, this is problem 3 on the final exam. It says this final exam review. This is the part that says to solve equations without a calculator, so this will be on the non-calculator part of the exam. So there's a couple ways you can do this process. So when you see a problem that's exponential, there's two things you can do. You can try to rewrite it so it has the same base. So that's how we're going to solve A and B. We can rewrite it so it has the same base. That doesn't work on D because D is hard to write. 10, e to some power is 10. So for part A and part B, since they have bases that are not E, we're going to try to rewrite these so that the bases are the same. So in this case, we want to look at making these both the same base exponent y, or base number. There is no base there. If you multiply 4 times 4 times 4, you don't get 32. So we're going to have to reduce this even more. So 4 has to be reduced to a base of 2 because 2 to the second power is 4. So 2 to the second power is then raised to the x power. And I think 2 to the some power is 32 if we think about that. 2, 4, 8, 2, 4, 8, 16, 32. So that's 5. 2 to the fifth power is 32. So that means that now that we have the same bases, the exponents have to be the same. So the exponents here are 2x, and the exponent here is 5. So that's going to be 2x equals 5, because the bases are same. So x is 5 divided by 2, or you can write, and that would be fine to leave it as a fraction, or if you want you can write 2.5, or you can write it as 2.5. Any one of those answers is correct for part A. For part B, we do the same thing. Since they have the bases of numbers, we're going to try to equate those bases. So we have 5 to the 1 minus 2x, and then we're going to have 1/5. Well, we have to rewrite 1/5 with the base of 5. So 5 to the 1 minus 2x, because 5 doesn't have a lower value that it goes into, like 2 went into 4. So we can reduce the base there. Here 5 is a prime number, we can't do that. We need to know here that 1/5 is equal to 5 to the negative first power. It's the reciprocal of this with the exponent that it has here, which is 1. So then we would write since the bases are now the same, we'd say these exponents can be equal. So we'd write 1 minus 2x equals negative 1 and solve. So we would subtract 1, so we get negative 2, and x is equal to 1 in this case for part B. Now, if you see a problem on a test where you can't see the bases are the same, if it's a logarithmic problem like one of these down here, what you're going to want to do is you want to convert that to exponential form. So in part C here, we have log base 5 of the x equals 3. Well, this is the base, so exponentially that's the base. The logarithm always equals the exponent, and this is what it's going to equal to. So base exponent equals this value here. So basically the answer to that is 125, because 5 to the third power is 125. And we're going to do that on E and F also. But let's do D first. D is e to the 3x is equal to 10. So we can't really use the equating the bases here because we can't rewrite this as e to some power. We don't know what that is unless we had a calculator, and we can't use one here. So we're going to rewrite this. So log base e of 10 equals 3x. So we can solve for x this way. All we would need to do is divide by 3. And we need to rewrite log base e. Log base e is ln. It's that log, so we have a specific name for it. So it's ln of 10 equals 3x. So the exact answer here is ln of 10 divided by 3. we don't have a nice, it's not a nice number, and like it's 125 or 1 or 2.5. So it's ln of 10 divided by 3 is the answer to D. All right, E and F, we're going to rewrite those. E is log base 3 of 3x plus 2 equals 2. So as we did on the previous one on D here, we're just going to rewrite that. So the base is 3, the exponent is 2, and it equals 3x plus 2. So we solve that. We have 9 equals 3x plus 2. We subtract 2 and divide by 3. So if we subtract 2, we get 7, and we divide by 3, so it's 7 over 3 is the answer to this one. And you can leave it like that, or you can write it as a mixed number as 2 and 1/3, or I wouldn't write it as decimal. It doesn't come out to be a nice decimal like letter A. Okay, and now the last one here, F, we have ln of x plus 5 minus 2 equals 1. So the first step here would be to add 2 to both sides, so that we have ln of x plus 5 equals 3. Once we do that, then we can convert it just like we did letter E, and just like we did in the ones previous on that, before that one as well. So the base on this one is not 3. Okay, it is actually E because of the ln. So it's e to the 3rd, there's the exponent, equals x plus 5. So your answer here is going to be e to the 3rd minus 5. We don't have a calculator, we can't figure out exactly what that is. So when you're doing these problems, we're either going to equate the bases if we can, if they're both numbers. Equate the bases, equate the bases. If we can't, we rewrite it so it's in another format. Log changes to exponential. That's what C did, that's what E did, that's what F did. All the logs change to exponential. If it's in exponential, we change it to log. Okay, so that's what that worked.